Tell me to go.
Yep, just a minute. All right, we're going to get started in about 1 minute. And it seems like we've got folks online as well, so hopefully you can hear the audio okay. You can't hear me right now? You can? Okay. All right, thanks everybody for joining today. I'd like to introduce Elad Nafshi. Elad serves as our Chief Network Officer, and he's an Executive Vice President at Comcast. He's in charge of our unified core and access network. So basically the entire network end-to-end that supports all of our products. So it's a huge technical organization, and he's got tons of experience and energy, but I'll let him continue from there and begin his talk. Thank you for joining us, Elad.
Thank you so much for having me, Jason. Thank you everyone for being here, both in person and virtually. It is so good to see people again. And it's so good to to be able to interact in these forums, and I really appreciate everyone, both virtually and especially here in the room, for taking the time and joining us. I'm going to be describing our path to what we call 10G, which is really the continuous progression on the network as we continue to work and grow our connectivity business. Okay, I will have time for questions at the end. So, feel free to ask away. And in the meantime, let's just get right into it.
And Elad, as you speak, bring the mic a little closer
Sorry.
for the stream.
Yep.
There you go. Thanks.
Is it better now?
It is.
Excellent. Well, first and foremost, welcome. Welcome to Philadelphia. Welcome after a very long pandemic where we all spend way too much on looking at video screens. Comcast is proud and happy to be sponsoring this event. I want to thank Jason Livingood, who's really been absolutely instrumental in everything that we do here and in other forums. And it's super exciting and candidly an honor and a privilege to be able to host this great event. I also want to thank everyone, each and every one of you, for all the hard work over the years in making internet delivery what it has been. Right? If you really take a step back and think about this, March 13th, which was a Friday of 2020, we all went home, okay? And the network in a day needed to adapt to a scenario that none of us really expected, right? Who would have thought that in our lifetimes, we all would go home, jump on Teams and Zooms and whatever other video communication that you're using and stay there for 2 years straight. And really be able to adapt and grow and add additional subscribers to the network while we were doing this. Truly unprecedented. And it really speaks to the robustness of the engineering work and work that we've done together as an industry, and I mean industry in the broadest sense of the word, in order to harden the internet delivery to the point where in this country, we were one of the only countries in the world where we did not need to go to Netflix to ask them to downres their video delivery. Europe, other parts of the world, not here. And I take quite a bit of pride in that. I really do, is having the opportunity to lead the team as we've done that. And I had a great discussion earlier with Stuart at Apple, who commented about the improvements that we've done in latency throughout all of this. And that, I think, again, that speaks volume to the technical leadership that comes from this organization, and many thanks for that. Okay, let's start talking about our actual roadmap. So first and foremost, for the folks who are not familiar with Comcast, or maybe familiar but don't quite understand how big our network is, it's really big. It's really, really big. When you really look at the network end to end, over 1 million miles of fiber and coax plant spread across the entire US, 39 states and the District of Columbia, where we service customers throughout that footprint. In terms of the delivery, how many transactions are we actually carrying through? And I think that that is such. I'm trying to balance between all these screens, so that you could still see the screen, and I could not get out of view for the lens. 1.3 trillion DNS lookups every day. 1.3 trillion. Capacity literally doubling on the access network every 2.5 years. So think about it this way: Comcast has been in the high-speed business since the late 90s, right? And every 2.5 years, we need to double what it took us to build 30 years. Pretty amazing. And when you look at the investment that we continuously put into the network, in 2021 alone, and I'll talk about the stats of 2021 in one of the next slides, we've invested over $4 billion into the network, and over $20 billion over the horizon since 2017. And this year, we're continuing with our investment in the network, because capacity continues to grow, our customer needs continue to evolve, and my team's job is to make sure that the network would always be infinitely scalable, and will be able to never hinder business growth. Okay, so let's go into what 2021 was, and it's funny to summarize 2021. We're almost in August of 2022. But I thought it would be interesting to kind of take a step back and look at where we come from before we talk about where we head into. As much as we saw internet growth in 2020, and we saw explosive internet growth and added millions of subscribers to our network, which we're very happy to do. In 2021, we continue to grow usage. Okay, both downstream and upstream. So downstream continued to increase at peak at 11%, upstream increased by 5%. What's really interesting in all of that is that while capacity continues to grow, the customer needs are still very much asymmetrical. Okay, there's a lot of buzz around symmetry this and symmetry that, right? But the reality of it is that at the height of COVID, and you see it, here in terms of the ratios. At the height of COVID, we saw downstream to upstream ratio be at 12.4. Okay, in the second half of 21, as we kind of all were coming out of our sheltering in place, that went back up to over 14-1, which is where it was prior to the pandemic. Okay, and so the reality of it is that the network is still very much a downstream delivery network. Okay, it's not to say that upstream is not important. It is, and we've seen some pretty significant, obviously, traffic increases on the upstream, driven by video telecommunications, but it's still very much driven by downstream consumption, primarily entertainment services. That's not a surprise, right? And as you see, those OTT services continue to proliferate. I just saw a research note today. TiVo is saying that the average consumer has 9 different streaming services. Unfortunately, there's only 24 hours in a day, right? So, you just, there's you reach a substitutive effect in terms of what they actually watch. But those are the growth rate that we needed to accommodate and continue to accommodate from a subscriber standpoint. And then, last but not least, while video conferencing share of peak network traffic literally doubled during the pandemic, okay, doubled one day, it's still only 5%, actually less than 5% of the total bits carried on the network. Okay, now if this guy has anything to do with it, we'll all be broadcasting at 8K out of our home. But the reality is that for the current subscriber trajectory, it's just put that into perspective. Okay, let's talk about what it means to the network. And what I try to show here is both kind of the physical topology, but also the spectral topology of what the Comcast network represents. So 60 million homes, the vast majority of the network, which I'll start down below, is rated at 750 megahertz of spectral capacity, okay? Of which the small part of, which you see down below on the left-hand side, between 5 and 42 megahertz is dedicated to upstream. Everything else is dedicated to downstream and is really shared by the various formats of DOCSIS over cable delivery and traditional video channel deliveries. While all of our lineup is carried in IP, we still deliver channels to traditional set-top boxes that are QAM-based. Okay. In terms of the physical plant, what it looks like for high-speed data delivery. Traditionally, we relied on separate pipe delivery. The CMTS, or the cable modem termination system, that delivers the DOCSIS signals to our high-speed data subscribers, and an OLT, the optical equivalent of a CMTS that delivers services to our fiber to the home subscribers. Okay, the vast majority of our delivery is over DOCSIS, but we do have parts of the network that are fed with fiber. And what you see here is a typical cable architecture, which relies on analog fiber from the CMTS, which resides in a local data center, typically closer to the subscriber because of the analog optics limitations, feeding an analog node. The reason for that is historical. It's the technology that existed when the two-way cable plant was built. And then we use amplifiers to basically amplify and extend the RF reach all the way down to the home. What you're seeing here in cable lingo is something called N+5, the node plus 5 amplifiers on this cascade. Okay, and this is kind of what a traditional cable network looks like, not just for Comcast, but among our other cable brethren. And the challenge with this is really twofold, right? Number one is, notice that while the network is asymmetric, there's obviously a very small sliver of capacity that is available to be sent upstream. Those are not easy things to fix because they're really limited by rated devices in the network that are able to pass or not pass frequencies in order to change the number of lanes that are dedicated to upstream and downstream delivery. Okay. We've spent a lot of time and great innovation led by Dan Rice, who's sitting right here, on a platform called Octave, which was rushed to market during the pandemic and is really the first time where we've implemented AI and ML in real time across our network in order to optimize the bit delivery to the individual customers, right? Because network conditions vary across the board. The signal down to my house may be impaired by LTE interference, or maybe I have a connector that needs to be tightened up, which is sending noise upstream, and that may be impacting the efficiency of the bits that I may be able to deliver to home. And so Octave, which is the platform that we built, is able to make those decisions in real time with real-time polling. And so the bit delivery down to Dan Rice's home may be better than it is for me, but we both are getting the service that is optimized to the then current network conditions. Okay. And what we've done is we've taken a smart network and we made it brilliant. And by doing that, we were able to generate another 45% of capacity at the time that we needed it the most by relying on pure software innovation. So really exciting times, even during pandemic. Okay. Now the challenge that we have is analog optics in a world of everything digital, a CMTS, which is an appliance-based architecture, in a world that is all web scale and web speed. How do we evolve the architecture to be able to rise to the network challenge? And about 5 years ago, I got this amazing opportunity to really take this on at Comcast and lead this virtualization transition across the board. So why don't we go to the next slide, please? And what you're seeing here is the continuous evolution and innovation on the access network. And I'm going to start with the spectrum, and you'll see that what we're doing is we're doing two things. Number one is we're increasing the size of the pipe, okay, to either 1 gigahertz or 1.2 gigahertz. Why are we doing this? Because the customer needs continue to evolve, right? How do we continue to have the pipe that is there, whether the capacity is needed today or whether it's going to be needed 10 years from now, right? Those are very large, lengthy upgrades that we need to go through. The second piece is that notice that we're increasing the amount of capacity that is dedicated to upstream by executing on something called mid-split. Okay, there's another split called high split, which extends the upstream frequencies all the way up to 204 megahertz. The reason why we chose mid-split is you see that guard band, that white space in between. It's there, so that we can continue to deliver video services to cable cards and other retail devices uninterrupted. Okay, and it's really important for us that as the network progresses, we're not interrupting or disrupting the customer delivery from a service standpoint, even on legacy video, QAM video, not just legacy. What we're also doing is that we're virtualizing the entire delivery system. And so we have launched several years ago what we call our virtual CMTS. By disaggregating and separating the hardware from the software, we're able to innovate in web scale and web speeds. We're running on Intel-based platforms instead of proprietary appliances. Put that in perspective, we're on our second generation of that platform, about to transition to the third generation of that platform, all riding on Intel's Moore's Law coattail, with effectively enabling to double the density and capacity, riding Moore's Law rather than reliant on proprietary chipset applications. We're transitioning to brand new digital fiber capabilities, which enable us to extend the distance, on the physical plant, which enables us to invest more into what we call the critical infrastructure. How do we make sure that we have backup power, backup cooling, backup everything in a world where the power grid is suffering from the weather events that we all experience every day. If you walked outside, today or yesterday rather, you'd understand what I'm talking about. And then the amplifiers on the network are upgraded in order to pass these additional upstream capabilities to fully take advantage of these speeds. This is something that we're doing across our network right now and working very hard because one, it enables us to literally triple the amount of upstream capacity that we're able to deliver, significantly increase speeds on the upstream, and really drive a lot more usage if and when customers are going to demand those additional upstream services driven by gaming or VR or whatever it is that will come. Okay. If we go to the next slide, please. We're not done, right? And when we say we're not done, is that's really a stepping stone into evolving our network into what we call DOCSIS 4.0. In this case, it's the full duplex version of DOCSIS 4.0. There's an extended spectrum optionality to the DOCSIS 4.0 spec. And what DOCSIS 4.0 enables us to do is deliver multiple gigabit symmetrical services on the same coaxial network that we're putting in place with our network rebuild. Okay. And what's really exciting about this is, take a step back. For the first time, we talked about the asymmetry and the frequency dedication or separation rather between upstream and downstream and how much of the plant is dedicated to downstream. What FDX, DOCSIS 4.0 FDX enables us to do is with advancement in compute, we're able to overlay I need you to mute. It's the story of my life, the muting. You're on mute. There you go. So what, nope. No, you're not on mute. It's okay, no problem. It's the story of our lives really over the last 2.5 years. But that's why it's so great to be here with you. We could control that. So what DOCSIS 4.0 FDX does is enables to overlay upstream and downstream frequencies right on top of the other with echo cancellation innovation, which we're working to develop and build into the plant, and be able to service those multiple gigabit symmetrical services on this while still maintaining, and you see it, down below, all of the subscribers that have equipment that is not compatible with DOCSIS 4.0. Okay, so the mid-split modems will continue to function, the legacy video delivery will continue to function, and all of that we'll be able to do on our coaxial cable. I had the privilege of demoing this technology at Cable Labs back in April. We were able to demonstrate 9 gigabits down and 5 gigabits up on this service. And what's really cool about this is with the virtualization innovation that we've worked on for the past 4 or 5 years, we're able to do this as a software download on the virtualized platform. Okay, electronic upgrades to the nodes and the amps, and now you have a coaxial cable plant where we're able to deliver multiple gigabit symmetrical services without needing to dig up everyone's front yards and everyone's sidewalks, and an 8-hour fiber installation and everything else that some of our fiber brethren are dealing with. That's the innovation. That is the Comcast commitment to continuous investment in the network, in our technology, and into products and services that our customers continue to demand of us as technology continues to evolve. Super exciting to see it happening. But we're not done there. Let's go to the next slide, please. I talked earlier about the low latency delivery and what we've done in terms of active queue management during the height of the pandemic, and how, and again, Dan Rice's team here really helped us to optimize the CMTS delivery configurations so that we don't just take care of capacity and we don't just take care of speed. Yes, we deliver gigabit services to more customers than anyone else. But speed is one element. The actual effectiveness of the bit delivery is as critical. And we have some pretty pioneering work that is already underway in terms of DOCSIS 3.1 low latency implementation, both on the network and on the Wi-Fi side of things, so that we could deliver end-to-end low latency DOCSIS delivery sub 10 milliseconds across our entire network, and be able to do that in great scale. So pretty exciting, innovative work still ahead of us. I haven't even talked about how the same virtualized platform effectively abstracts the wire delivery. And so I mentioned earlier the fiber to the home delivery that we have. And we, with the virtualized platform and the distributed access architecture that we put in place, we're able to deliver those multiple gigabit symmetrical services on whether the fiber is coaxial or whether the fiber is or whether the wire is fiber. Because again, the customers don't care whether there's coax in the black wire or whether there is a glass in the black wire. They want to make sure that the products and services that they rely on, they continue to deploy. With the virtualized architecture, with the digital connection, what I am mostly excited about is the real-time visibility and the real-time traceability that we have to the service end-to-end. It's a digital connection. It's now doesn't rely on polling technology anymore. It actually streams the real-time customer experience across this network in real time so that we could act on it. I mentioned the Octave AI engine that we built for bit optimization. Imagine, if you will, the same thing for fiber connectivity. Imagine the same thing for RF impairments on the network that may or may not be disrupting customers. Imagine, if you will, service interruptions where we're able to detect in 5 seconds instead of polling technology, which is ultimately limited by the CPU and the appliance and so on and so forth. And so this architecture, beyond the fact that it's going to be faster, beyond the fact that it's going to deliver low latency like no other, is truly extensive. It's truly broadly deployed. We don't dig this side of the street or that side of the street. All of our customers are able to experience gigabit speeds today, and they'll be able to experience even better in the future. So that's my my story for the path to 10G. And I'll pause here, and I'm happy to take any questions that you may have, whether it's here in the room, and let me start in the room, and then we could jump in and take any virtual questions. And Stuart, go ahead. Yep.
Okay, that's better. I don't have a question. I just came up to thank you for your presentation, to thank Comcast for its ongoing support of the IETF, to thank all the Comcast engineers like Jason Livingood and others that I work with for the amazing work you do, being on the forefront of creating new technology. And I'm not going to name other names, but there are other ISPs and operators who are not here, who are very clearly playing catch up. And 5 years from now, they'll be finally figuring out what you're doing and realizing why they're falling behind. So wonderful work that you're doing. Thank
Well,
you.
it means a lot coming from you personally. And it means a lot, for me, is having the opportunity to lead this team through this transition, because this is not easy. Okay, this is not. And when you're in the tip of the spear of technology, guess what? The first year and a half of working through the virtualized platform, we did not sleep, honestly, because it looks great on PowerPoint, right? But when you try and put this in front of paying subscribers, you run into any possible corner case you may run into. And abstracting hardware from software, really is easy to say on PowerPoint. It's not easy to do in practice. But with all the lessons learned, I'm so proud to see what the team was able to accomplish. And you see that with the millions of subscribers that are on this platform right now. So it really means the world to us. It really does. Thank you.
Thank you. And I just realized poor microphone etiquette. I didn't say who I am. This is Stuart Cheshire from Apple. Thank you.
Thank you.
And we have one in the queue. Yoshiro asks if we are providing IPv6 to customers yet, and if so, what sort of size prefix length do we provide?
That's a shoe in for you, because you've launched IPv6.
Yeah, the answer is yes, we do, and generally /56 or 60 for the home business.
And I would say what really makes the Comcast network unique is not only are we providing IPv6, we're providing IPv6 multicast on the video side, which is quite the complication from a delivery standpoint. It is a very, very unique Comcast case, because when you look at some of the third-party applications, at the NOS level, it's not a requirement that is very broadly adopted, across the industry at large. We had to do it because of the way our video delivery pipeline is. Any other questions?
Hey, Elad. So, my name is Amir Burjandi. So
Sorry, just go right up to the mic so the stream can hear you.
Can you hear
go.
me?
Perfect.
Yeah.
So Amir Burjandi. So so you actually did a very good, interesting job, and congratulations. Are you looking to expand this sort of work, to other parts of the network? Because this is one small, it's not a small section, but it's one part of the network. So.
Wow. Small. I heard it.
Yeah.
So the short answer is yes, but let me give you the long answer too, okay? We don't do technology for the sake of technology. We don't, right? As much as, engineers like to do that, that is not, that is a means to an end, and the end here is the customer experience. It's reliability, it's the scalability or continuous scalability and continuous growth of the network, okay? When you look at the other side of the network, the smaller side of the network, the core network, is, I'm just joking. When you look at the core delivery, right, the core delivery today very much relies on appliances up and down the delivery for various historical reasons, right? This has been a vendor-led, vendor-driven industry that had very little incentive to innovate, disrupt, okay? And, it served extraordinarily well and continues to serve extraordinarily well. But I look at some of the work that, for example, AT&T has done in terms of virtualizing their core network and driving both ASIC and NOS diversity onto the core network. I look at the progressions in photonics across the transport layer. And when you see innovations like zero optics and others, you know, begin to come in, and how those get paired with the aggregation routers, and the, you know, the two coming together, I think that there's tremendous opportunity on the core network. We are actively looking at, you know, what the right technology decisions are for us. But again, to me, beyond the technology choices and beyond the hardware and software abstraction, to me, it's the real-time visibility and how, for example, we rely on GNMI in great scale, right? Not just at the access layer, not just at the, you know, close to the customer, but really up and down, and be able to rely on real-time streaming, real-time alarming, and real-time telemetry to start to really drive AI at a grand scale across all of that. And that's something that we are looking into, and a lot more to come.
So, can I add the second question?
Yeah,
if
yeah,
there's
yeah,
any?
go.
So, first of all, I didn't mean to say some. I just said like one portion of the network. Maybe that would be a
You hurt
better.
my feelings. It's too much.
Too
Too late. I'm sorry.
I'll just allocate that English as a second language. So, um, but so you actually bring a very good point of like, you know, AI. So industry is talking about self-healing networks for a while, all that stuff that comes into picture. Is that something that do you think would eventually, I mean, and everyone's talking about it for the last like, you know, 6, 7 years. So where do you see, in your opinion, where that would, do you think the self-healing network would, we will see that in the next couple of years, or it's a 10-year?
So I will tell you that again, with the Octave example, as it is right now, right, we are effectively modulating around network impairments as we speak, millions of times a day today. Okay, and that's on the you know, the access network. Without going into too many details at this point, we have a platform that we call NetIQ, which you know, operates. You could check it out online. We actually have a, you know, a couple postings on that that does that on the core, but we're just getting started. The real power here is how do you connect all of them together? Because, you know, picture, if you will, you know, the following. I have 4 boys. 2 were in college during the pandemic and came back home because, you know, they closed it, and then 2 are still in school. And 15 seconds after the internet goes offline, one of them, at a minimum, is in my home office, right, letting me know that the internet is down. They're like internet probes. It's great, okay? And now the real question becomes, where in the network is the impairment? Where in the 1 point, you know, something million miles of cable, okay, fiber or coax, the impairment is, okay? And the problem that you're dealing with kind of, you know, vertical appliances is that they don't carry across very well, right? But if, for example, the issue was I had a big local metro area fiber cut, okay? If you, everyone I'm sure has called their cable company to try and get service, and the first thing the on-hold message tells you is reboot your modem. Okay, well, you can reboot your modem 1,000 times. If there's a fiber cut to your area, that's not going to help, right? And so how do we deduplicate the alarms? Because think about the alarms that just went off in our network. The cable modems were streaming that they lost connection, okay? The smart network, the amplifiers, the nodes, and the VCMTS said, we're not getting traffic, it's not coming through, okay? The local network said, well, I lost something northbound, and now it's how do you shoot the fiber in order, with an OTDR, in order to pinpoint exactly where the fiber disconnect is. And that's what we're working on right now. How do you tie all of these indicators together into a coherent alarm that not only pinpoints where the breakage point is, but also then has the intelligence to message to our customers what their expectations are. Okay. And so it's not just about the self-healingness of this, is what do you tell the end customer? Okay. Don't reboot your modem. There's a fiber cut in your area. Fiber crews are aware of the issue and are working to restore service. The ETA is 4 hours. And that ultimately is what the network goal is, right? Because that's what our customers expect of us. And that's what we're working on.
Right. Thank you so much.
Any other questions?
I got that one already. Yeah. Next question. Yeah.
Yeah, please.
Hello, I'm Robert Jackson. So I have a question. Do you have numbers of your TCP versus UDP traffic percentages lately? And is it affecting your engineering of the network in any way?
I don't think we,
Yeah, I don't think we've shared any of those stats, but yeah, we're watching closely, what's happening with Quick and all these kinds of things. I don't think yet it's changed the way that we do engineering.
Yeah.
It's all IP.
that's exactly right. Okay, any other questions from anyone? Any other questions online?
I don't see any more online. Is there another one online?
Yeah.
Oh, sorry. I don't see the same screen. Maybe the
Sharon,
person that's
okay.
online can, we lost the meet echo here. Maybe the person online can ask your question, go off mute. Sharon?
Yes, hi, this is Sharon. I'm thinking of a very large upstream application with connected cars hitting a access network wall with cellular. Is there any thought of combining DOCSIS with wireless LAN in order to free up this jam? Any plans, any thought about it? Thank you.
So Sean, it's a good question. Let me answer it this way, okay? Comcast is not a wireless company. We do offer cellular services, but they're through an MVNO with Verizon. We do have a very, very large Wi-Fi network. In fact, it's the largest in the U.S., which we use for both customer benefits, but also as a way to offload cellular minutes and help with the economics of the MVNO. As such, and really driven by that, obviously, what's right for the Comcast network, may be different than companies like Rogers, that is actually a wireless carrier and has a tighter integration. And so, Shawn, I really think that the answer to your question is probably, but it really depends on the actual operator and the unique services that they provide. Okay. Any other questions? Yes.
Last one, and then
we'll wrap up.
yeah, we'll wrap up.
Yep.
Sorry, not a question, but a comment. Jason Tucker from Comcast. Following up on the IPv6 question from earlier, not only are we delivering IPv6 to customers, but we were doing it at a large scale like 10 years ago. So IPv6 it's really integral to what we do at a lot of levels.
Yeah, totally.
Has been.
And you're 100% right. And Jason, thank you. I would say, last comment on this, on the IPv6 piece is, it's so ingrained to everything that we do from a network standpoint, we could not scale. At some point, we were the largest consumer of IPv4 addresses, and we literally hit a wall. So, this has been a instrumental for us, to your point, for many, many years. Yes, last one, and then they kick me out.
Hi, Paul Curtis, Sienna. In talking about the monitoring and troubleshooting, you mentioned GNMI. I guess I'm curious to the extent you're using GNMI just for monitoring or also for all network management, and if there's anything you can say about your progress there, where you guys are at in rolling that out.
Yeah, so I'm trying to think what I could say. I could say that I could say this. We're very excited about the fact that it is a common standard, even though every vendor, Sienna, has a different implementation of GNMI, right? Same for the Nokia person, back there, and so on and so forth. Okay, and so part of an operator challenge is what pieces of it can you take that you could fairly standardize, that you could then feed across, this diverged ecosystem, that you could actually act and operationalize. Because at the end of the day, think about the ops people that at 2 a.m. need to get an alarm and do something with it. Okay, and that's where the challenge has been. I want to say that in parts of the network we're further along. In some parts of the network we have, we're just in the beginning stages of this. But again, it's exciting to be able to leverage a common spec across these as we're maturing the actual delivery. Does that make sense? Thank you. Okay.
Great. Well, thank you very much, Elad. Appreciate it.
Thank you for having me. Thank you for coming here. And again, thank you for your thought and technology leadership. We could not have done any of this without the great work that you're doing across the industry. So thank you.